Hello and good afternoon. CTS265, Section 840 students for the Fall 2016 semester at Anne Arundel Community College. This is the CCNP route course, and this afternoon's video tutorial is going to be a tutorial and solution set for Cisco Learning Labs activity challenge number 9, where we're going to be taking a look at implementing path control. So we're going to need to recall all of our PBR and IP SLA skills from the previous chapter, specifically from chapter 5. So let's go ahead and take a look here. We've got excuse me, EIGRP already configured between HQ and branch 1, and this diagram should look very similar with the exception that we've now added in off of branch 1 here. You can see we've got an Ethernet link, we've got a serial connection, and we also have another Ethernet connection out to the WAN. So we need to make sure that by default, or actually by default, all traffic flows over the Ethernet WAN link. So that's going to be Ethernet 00, and we're going to trace that out to validate that. We want to redirect web traffic so that it travels towards the HQ router. So all web traffic should be going across this serial link right here between HQ and branch 1. And then it says, furthermore, all other traffic from the notebook should go via branch 2. But you need to make sure that branch 2 is reachable before redirecting traffic to it. And so that should immediately trigger your thinking of verify reachability, right? Because if we're using PBR, which is a static solution, and remember, all that policy-based routing is it's allowing you to override the default destination-based routing and changing it to source-based routing. But if we want to use it or use it with IP SLA, we need to make sure that we verify reachability, and when we get to that, we'll chat a little bit more about that. So let's go ahead and dive in. The first thing that we're going to do is basically very straightforward 3 steps to take care of the web traffic. So let's go ahead and jump on branch 1. And it looks like the majority of the work is probably going to be on branch 1 here because this is where we've got notebook and the PC. So let's pull branch 1 up, but then I'm going to get the notebook up here as well as the PC. And so from the PC, if I were to take a look here, let's get the job aid up and see what the IP is. So it's going to be the same, it looks like pretty similar IP scheme that we had earlier in the discovery activity on PBR. And we're going out to this 192.168.100, and let's see 100. And I'm assuming, yeah, okay, .1. Sorry, I didn't see a little .1 right there. All right, so 192.168.100.1. So let's trace right now from our PC. Let's get into privilege exec, and let's say trace 192.168.100.1, and we're going to kick off the same trace on the notebook to see if we get similar results here. 192.168.100, whoops, 100.1. All right, so we've got that set up. Excuse me. We'll come back to the PC here, and it looks like we had an ARP request that had to make its way out there. So we go to 192.168.110.1, and we probably remembered that from the discovery activity. That's our default gateway. That is the LAN-facing interface on the branch 1 router. We then go to 10.10.10.1. So if I get on the branch router and we say show IP interface brief, let's see what interface I would have gone out there. So we're 10.10.10.2, and that's that Ethernet 00. So it is that interface right here going toward the WAN. So the PC clearly goes to branch 1 router right there, and then it jumps out to the HQ router via the WAN link right here. What about the notebook? Exact same thing. So we have validated that all traffic is actually flowing as we would have anticipated. So again, notebook traffic comes in and goes up through the WAN to get into the HQ router, and the PC does the same thing. And so now what we're going to do is we're going to go ahead and we're going to make a change here, at least for web-based traffic. And so we're going to say that any, and it didn't specify just the notebook web traffic or just the PC. So based off of the scenario, we're going to grab all web traffic, and we want all web traffic to flow via this way. So for that www traffic, we're going to change things a little bit here. All right. So remember from PBR, it's a very straightforward process. First, we need to match the type of traffic that we're looking for. And so we know that we can't use a prefix list. So remember that. We can't use a prefix list to accomplish this. So with PBR, we're going to be looking at access lists. And since we know it's web traffic that we're looking for, and only web traffic, we're going to be doing an access list, obviously an extended access list, because we're trying to match on a protocol and a port. In other words, TCP port 80 and TCP port 443. We're going to make sure we get HTTP as well as HTTPS. And so the first thing we need to do is create an access list, and we're going to go for a named access list here, and we're just going to call it HTTP underscore HTTPS. And that pretty clearly indicates by the name of this ACL that we're grabbing or trying to match HTTP and HTTPS traffic. And I actually forgot to put the extended in there, I believe, and let's make sure we're good here. Yep. All right, so IP access list extended HTTP underscore HTTPS. And then what are we going to do? Well, we're going to permit TCP. Now, remember, there's two ways that we could do this. I could deny everything else and then allow HTTP and HTTPS, which would be a nightmare, or I can simply permit the two protocols, right? Because we're trying to match here. I'm going to try to match on the two protocol and port combos that I'm looking for, and then I'm going to allow that implicit deny all at the end, or the deny any at the end, to pick up everything else. So here it's clearly easier to basically say permit TCP, and we're going to say it's coming from any and going to any equal to 80, and then we're going to do the exact same thing and say 443. So if I say do show run section access list, let's take a look at our ACL. So there's the ACL we have right now. If I say do show access list, and I'm probably going to have to say, I don't know if I have to put that in there, access list HTTP underscore HTTPS. There we go. So you can see we've got an extended ACL. There's our two statements, and we've got an implicit deny any at the end. So now that I've matched the traffic I'm looking for, now what do I need to do? So I've created the ACL, and I've matched the traffic I'm looking for, and I've denied all the other traffic I'm not interested in matching. So all I'm going to match is www and 443, or 80 and 443. Exactly. Well, what I need now is I need to make sure that we go ahead and create the route map. So this is where I would say, and let's get out to context-sensitive help here. So I would say route map, and I'm just going to say HTTP, HTTPS. We'll name it the same thing as the ACL, permit 10. Now remember, if I don't put permit 10 here and I hit enter, what's the default? Exactly, the default is going to be permit 10. So I want to match IP address, and remember this is very critical here. We can do numbered ACLs, we can do named ACLs. If I did a prefix list, I would have to put in the keyword prefix list, but this is PBR. We can't use prefix lists, and we're not going to use a prefix list, so we're going to be using an ACL. So match IP address and then the name of my ACL, HTTP, HTTPS. Now, if I match it, right, if I match the web traffic via this route map that references the ACL that's doing the matching for me, what do I want to do? Well, remember, we want the next hop, or we want the route that the traffic is taking to go not to the WAN, right? We want it to come straight over here to HQ. So let's take a look at HQ real quick, and we'll go from user exec to privilege exec and say show IP interface brief. And that serial, what interface is that? Serial 20 interface is 10.10.21. So I create an ACL, an extended ACL in this case, and specify the traffic I'm trying to match. I then call that in a complex ACL, which is the route map, which we're going to be applying to the interface with an IP policy statement. And if I match any port 80 or port 443 web traffic coming into the interface, the LAN facing interface, we want to set the IP, whoops, sorry, get in the window here. We want to set the IP next hop to what? Exactly. 10.10.20.1. That is that serial interface on the HQ router. All right, so we've defined the access list to match the traffic. We've defined the route map so that we can apply it to the interface. Now let's get into the interface, which is going to be Ethernet, and I'm definitely going to need to take a look at this. Those are Ethernet 00. It doesn't say, so it's going to be, let me do a quick check here, do show IP interface brief for the 192, Ethernet 02. So we're going to get into Ethernet 02, and this is where we say IP policy, and this is why we need the route map. Because you're probably wondering, well, why do I need an ACL, and then why do I need a route map? Well, you need both, because we need the ACL to match the traffic for us. We need the route map to then take action if there is a match, allowing us to set the next hop for the web traffic. And we need the route map. You can see I can't put a prefix list here. I can't put an ACL here. When I say IP policy, PBR, it is mandatory that this IP policy statement get a route map as its argument. And so we call that HTTP underscore HTTPS. And this is going to apply that route map onto this interface. And so let me see if this is smart enough. If I were to say telnet, okay, let's see if it allows me to say 192.168.100.1, and can we put in here a port? www, let's see. So connection refused by host, or let's see if I can do a trace to 192.168.100.1, and can I specify, there we go, port number. All right, so let's trace to port 80. I was hoping it would allow me to connect in there, but I'm assuming it's not running a web server there. But we can trace it out, and we're going to trace it using port 80, because let's validate that what we just did is actually in effect. So the first hop should be 110.1, but now we should not go to 30.1. We should go to 10.10.21. And we go to 10.10.10.1. So this certainly did not do what we expected. Let's try from the notebook and see what we get. So let's say trace 192.168.100.1, and we're using port 80. So let's see if we can get this to work for us here. And again, it's interesting, the activity doesn't actually have you validate, but we should get a validation here if we're using port 80. So we hit our default gateway, and I'm going to try over here on the PC real quick to recall that command and say 443, and let's see what happens there. Yeah, so we're still going to 10.10.10.1, but again, I'm not sure if that is actually as a result of this being IOU, or, and I guess we're sourcing it from ourselves anyway here, so that should work. So yeah, and I'm wondering if it's IOU as the reason as to why this is not matching. So let's check the branch router again. Let's make sure. Interface Ethernet 02. And we clearly have our route map statement there. Do show IP access list and HTTP underscore HTTPS. Yeah, so we've got a single match that's taken place, which is interesting. Okay, so do show route map HTTP underscore HTTPS. And we've got a single policy routing matches one packet. Okay, let's go back. Let's check PC. Did we get any luck there? We did not. Notebook, we did not. Okay, and this may be why they don't have us validating this. But if it was working, that should match. Okay, let's go ahead now into the next phase, which the scenario is going to call for here. and that is that we've got to redirect web traffic so that it travels to the HQ router over the serial link. We did that. Furthermore, all other traffic from the notebook should go via branch 2. So we're going to want to set something up so that traffic from the notebook is going to go via branch 2, but you need to make sure that branch 2 is reachable first, right? So branch 2 needs to be reachable first, but the notebook traffic is going to go that direction. So we're here on branch 1. So let's do this from branch 1. If we punch out here, we'll go ahead and we'll set up the policy-based routing component, and we can piggyback this, and this will be a nice example of how we can piggyback the next statement that we need. Remember, the route map is nothing more than a complex access list, so it's going to evaluate each stanza in numerical order. So permit 10, permit 20, and then we have that implicit deny all at the end. So let's go ahead and create our access list here, and so we're going to grab everything else from the notebook. So we'll go ahead and we'll say access list, or actually we'll name it notebook. So we'll say IP access list extended, and actually it does not need to be extended, so I can just say notebook, because we're going to grab everything coming from the notebook, and the notebook's address is show IP interface brief. Whoops. Show IP interface brief is 110.10. So if it doesn't match the first route map statement, then it's going to come to the second route map statement, in which we're going to have an ACL called IP access list notebook. Whoops. Standard notebook. And this is where we're going to make our match. So we're going to say permit IP, and we could do IP host 192.168.110.10 going anywhere, right? So there is, and it did not like that. Let's see why it did not like that. Permit, oh, host, not IP host. Okay, permit host 192.168.110.10. And we should have had, that should be all we need. Okay, that should be all we need in this ACL. So now we need to do a modification to the route map that we already created. And remember, by default it did permit 10 first. So when we say route map HTTP underscore HTTPS permit 20. So we're going to match IP address notebook, which is our named standard ACL. And if we match it, we're going to set the IP next hop. And again, we want to go to branch 2 here. So on branch 2, if I said show IP interface brief, branch 2 is going to be 10.10.32, right? So we'll come back over to branch 1, set IP next hop to 10.10.30.2, and this is where, and actually before we do that, there it is. So this is where we need that verify availability. So before we send the traffic to 10.10.32, we need to verify that it's actually available. And the sequence to insert into the next hop will simply say 1, and then we're going to track that IP SLA, and we'll simply use, when we create the SLA, we'll simply use IP SLA 1 to track. All right, so now let's go ahead and say do show route map HTTP underscore HTTPS. And so that's what the route map looks like. Here's what we just added in. We're matching on the standard ACL notebook, which is going to match all traffic coming from the host notebook. We're going to verify the reachability of 10.10.32 first. And if it is reachable, then we're going to make that PBR change. But remember, what haven't we done yet? Exactly. We need to create the IP SLA. And so that we can just simply do an echo, ICMP echo. So we're going to say IP SLA 1, and we're going to stick with that number when we do our track statement as well. So IP SLA 1, ICMP echo. And what do we want to do? Well, we want to ping 10.10.30.2 because that's the IP address of the branch 2 router. Our source interface, we're going to source it from Ethernet 01. And how often are we going to do it? And if I back up here, we can see that here are my choices, right? I could put the frequency, put who the owner is, and the owner is just, so if I were to say owner, Travis from the network team, right? And that's just sort of like a comment. I can say frequency, and we're going to have this go every 5 seconds. And then now I need to schedule it, right? Because again, I'm just sending a quick ping up there. So IP SLA, schedule, and what is the SLA number? It's 1. The start time, we want to go now, and the life will be forever. Or I could put the life in seconds. So if I didn't want it to run forever, if I wanted to run for 24 hours, I could say 86,400. So we'll leave it at that. So now I'm going to track 1. And we're going to use, what are we doing here? Track 1, IP SLA, whoops, 1, entry 1. And that will do it. So if I say show IP SLA statistics, we can see here, right, that this is actually working. We've got 3 successes, a single failure, but every 5 seconds, right, the successes should be incrementing. And you'll notice the operation time to live is counting down constantly because we put it in there for 86,400. But take a look at my successes, right? So we have success here. So this is what the route map is going to be verifying the availability of. So now let's take a look here. Let's see. If I'm on the notebook and I say trace to 192.168.100, whoops, 100.1, we should go up to branch 2 because we are setting the next hop for traffic from the host 192.168.110, which is the notebook, and we're setting the next hop to go to the branch 2 router for all other traffic. Web traffic should still be taking that southbound, that lower serial link connection. So do we see 10.10.31, which is what we should see here for our second hop, or 10.10.32, sorry, it's the branch 2 router. And there we go. Take a look at that, right? So we've got success there, and now it should go down to the branch router, or the HQ router on that side, 10.10.41, and that worked perfectly. Let's validate from the PC here. If the PC traces to 192.168.100.1, should it go to 10.10.31? No, it should not. Remember, when we're doing this source-based match in the ACL, we never created an ACL that was matching the PC's source IP address. Our ACL is matching the source IP of the notebook. And you can see here, this is working just great. So we should go to 10.10.10.1, which is the WAN interface. So now what we've done is we've effectively been able to send the notebook traffic, non-www traffic. So we'll say all non-www traffic goes this direction. All www traffic, or www traffic goes that way for the PC and for the notebook. And then all of the PC's other non-www traffic goes across the WAN link. Get another W in there. All right. And so that, in essence, this is the Challenge 9 activity. The one thing that I wish we would have been able to see, and let me check one thing, is that when we traced using the source as, let's say, do show run, and I want to see, oops, sorry, show run, and I want to see, let's take a look at that route map, match IP address, http_https, set IP next hop 10.10.21, and https, permit TCP any equal www. Yeah, and I'm wondering if it's IOU is the reason as to why that's not working. Again, when we traced, we put in that port number of port 80, anticipating that that was going to work, and it did not. And it should have worked. It should have worked because these are correct. Everything we have in here is correct. Okay. All right. Well, this is going to wrap up challenge number 9. Enjoy the rest of your weekend, and I will see you all on Monday evening. Have a good day.